Okay, next question. We have this hard question that was brought up right at the start as well. What do we do to answer this kind of question? So, just in case my handwriting is a little bit too messy to read, I have 6 divided by 1 plus the fourth root of 16 x to the power of 8 y to the power of 12. So have a go at rationalizing and simplifying this question, and then we'll come back and do it together. All right, I'll give you 10 seconds to pause the video here. Okay, so hopefully you're able to get a decent way through this question. When we're looking at this, we see that we have a surd on the denominator or a radical sign on that denominator. Um, and we want to rationalize it. To do that, we want to multiply it by its conjugate. So we're using that technique where we're multiplying it by its conjugate. We have 1 minus the fourth root of 16 x to the 8 y to the 12. And then we'll do the same conjugate on the top as well. But before we do that, because that can get quite messy, let's actually see if we can simplify this and see what it can simplify into first. It might mean that we're writing less when we're doing the conjugate. So if we have 6 over 1 plus, so doing this, that 4, 16 is already 2 to the power of 4, we saw earlier. So we have 2 to the power of 4 divided by 4, x 8 divided by 4, y 12 divided by 4. Next line, we have 6 over 1 plus 2x squared y cubed. And I think that's actually as simplified as that can go. I was initially thinking that this would end up being a surd still on the bottom, but you can see that by not jumping straight into a complex conjugate and applying that rule, we've already gotten to the end answer, and it was probably much faster than doing all that messy work and then having to simplify it. Okay, so have a go at rationalizing the denominator for this question. I'll give you a few seconds to pause the video here and we'll come back and do that. Okay, hopefully you had a chance to work on that. So we could multiply it by the conjugate straight away. Again, it looks like we could probably simplify it a little bit beforehand. So 49 is a complete square of 7, and x you already have for same as what you've got here. I think the easiest explanation will be to bring the power in first. So you got 49 to a quarter, x to 4 over 4. And so the next step, we simplify this little bit. 1 minus 49 is 7 squared, so 7 squared all to the power of a quarter. So you're going to multiply your power, so 2 over 4. Let me just go into a bit more detail what happened there. So 49 to the power of a quarter is equal to 7 squared, also still to the power of a quarter. Power of a power is multiplication, and so that leaves 2, the 7 to the power of 2 over 4. Now, x, you have a power of 4 over 4, so you just got x by itself there. And 2 divided by 4 is a half. So that's equal to 3 over 1 minus 7 to the power of a half x. Now, anything to the power of a half is still a square root. So this actually simplifies to 3 over 1 minus x square root 7. So we still have a surd on the denominator, and we need to rationalize this. So the way we rationalize this is we multiply it by its conjugate. We'll have 1 plus x square root 7. 1 plus x square root 7. Expanding this out, we're going to have 3 plus 3x square root 7 over first term squared minus that second term squared. So 1 squared minus x squared, well, actually minus x square root 7 squared. And so you're going to bring that square into each individual term. So you're going to have 3 plus 3x square root 7 over 1 minus 7x squared. And that should be your final answer for that one there. Okay, here's our next question, and we'll make this one the last question for the Surds content. So we have a radical sign up the top. So the fifth root of 32 p to the 5 q to the 10 all over 1 minus square root 2. So have a go at trying to rationalize the denominator and simplify this question, and we'll come back to it. I'll give you 10 seconds to pause the video and give it a go. Okay, hopefully you were able to get an answer out of that. So we can rationalize the denominator by multiplying through the conjugate on both the top and the bottom. But this looks like a mess. So let's try and simplify this before we do that. Maybe we can get to something simpler and we're writing out less things throughout the way or throughout the steps. So the fifth root of 32. So let's bring this into the powers of everything on the top. So we have 32 to the power of 1 over 5, p to the 5 over 5, q to the 10 over 5, all over 1 minus square root 2. Now 32 is equal to, well, it's even, so let's see if 2's going to it. 2, 4, 8, 16, 32. So we have 5 2's, so it's equal to 2 to the power of 5. So our next line would become 2 to the power of 5. So this 32 is 2 to the 5 over 5, because we had that over 5 there, times by p to the 5 over 5, q to the 10 over 5, of 1 minus square root 2. So simplifying numerator a little bit further, 5 over 5 is 1, 1, and this would be 2. So we have 2p q squared all over 1 minus square root 2. So that looks like a much simpler version of the top. So let's try and rationalize the denominator now in this using this simplified part. So we multiply through the conjugate. So 1 plus square root 2, seeing as this is a minus, we're using pluses, over 1 plus square root 2. So expanding this through, we have 2p q squared multiplied by 2 square root 2 pq squared all over first term squared, because you have a take b times by a plus b, so it's going to have a squared. So 1 squared take the square root 2's squared. We have 2pq squared plus 2 square root 2 pq squared over 1 minus 2, and 1 minus 2 is negative 1. So it's not good practice to leave the negative on the denominator. So if you have a negative on the denominator, you can bring it up and make the whole fraction negative. But I'll just point out, if you have something like a plus b all over negative 1, that's the same as saying negative a plus b over 1. So you're putting it in brackets because that negative has to be applied to every term. So we're going to have negative 2pq squared minus 2 square root 2pq squared all over 1. And then because it's all over 1, it's just equal to that thing. So we're going to have negative 2pq squared minus 2 square root 2pq squared. And then for completeness, we can show an alternative form where you've just refactorized out the common features on that numerator yet again, back to what it was up here before expanding it, except you've got that negative out the front there now too. And we'll leave it there for this Surds content.